Hello, Algebra 2 students. Mrs. Myers here. Today we are going to be taking a look at Lesson 14, Day 2, which is more tangent graphing, but this time we're going to be doing a vertical translation. So in the last video, we did the parent graph of what y equals tan x looks like. We did vertical and horizontal dilations, and we did a vertical reflection, meaning over the x-axis. And we're going to revisit those transformations and just put one more transformation on top of it. So this will be the last day that we do tan graphing though. We are not going to do the horizontal phase shifts. It's not that you can't do them, you can, it's just that we don't need to go to that level for this course, so we're not. Okay, so just a quick little recap here for y equals tan x. We've got our different characteristics of y equals 10x with respect to sine and cosine. One important one is that there's an asymptote now, which means the graph extends towards positive infinity on one side of it and extends towards negative infinity on the other side of it. So there's no min and max anymore with respect to the tan x graph like there was for sine and cosine. There is a midline though. The midline is still the x-axis for the parent graph. And we do have to put a scaling of 1 to -1 on the y-axis, but they're just used in different ways now. Okay, it's still important to have it there so we can do our vertical dilations and vertical translations and such, but it's not for min and max. Okay, so just a quick recap again. We start our tan x graph at a midline point. Okay, so at 0 radians we have a tan value of 0, and then at 2 intervals later we get to our asymptote, which for the parent graph is at pi/2. And then halfway through that at pi/4, the y value for the tan function is exactly 1. Okay, so the value for tan of pi/4 is exactly 1, so it's important to note that there. And then as we continue on the other side of the asymptote, okay, continuing to go in the positive x direction, we start all the way down here at negative infinity, okay, just past pi/2 radians, start negative infinity, and we increase up to eventually pi, 0, which is a midline point. And then halfway between the asymptote and that midline point is, in this case, 3 pi/4 radians is exactly that y value of -1. Okay, so very, very important to note that. So anyway, if I want you to graph for me what y equals tan x plus 5 looks like, okay, so we're just going to take this graph right here and we're going to just move it up 5. Okay, so of course, hopefully we remember that anytime you're just doing some adding and subtracting in the equation, that it's a translation. And because this is outside the parent function, this would be a vertical translation. So it's just going to send the graph up 5. So what I'm going to do just beside it right here, okay, is I'm just going to give myself the x-axis all the way down here. Okay, and I'm going to extend my y-axis up quite a bit. Okay, so I need 1, 2, 3, 4, 5 there as my midline. So I'm just going to put a dotted line in there for my midline. Okay, just going to help me to see what the graph is supposed to look like, because right here, what this looks like with respect to the x-axis, that's what that graph still has to look like with respect to that midline. Okay, and then this point right here, which is at a y value of 1, now I'm going to need a y value of 6. Okay, to match up with that. And then this point right here, that was a y value of -1, well, that's going to go up 5, and I need a y value of 4 to match up with that. Okay, so I'm still going to have on my x-axis the 0, pi/4, pi/2, 3 pi/4 pi radian measures to make for one cycle. Okay, and then half right there at pi/2 is going to be my vertical asymptote, so I'll put that in. Okay, moving the graph up or down never changes that vertical asymptote being at pi/2, right? And then I'm just going to transfer the points over. So instead of 0, 0, it's now at 0, 5, because that went up 5, right? Instead of pi/4, 1, I'm at pi/4, 6, right? And the graph just goes up forever like that. And then instead of 3 pi/4, -1, now I'm at 3 pi/4, 4, right? Because that went up 5 units, right? And then at pi/0, that one moved up to pi, 5, right? And there we go. Okay, so that is what one cycle looks like. Past that would just repeat the cycle. Okay, so this is one cycle of tangent. If you continue to make the graph after that, it just looks exactly the same. Okay, so again, this is what one cycle looks like, and it's got a standard period of only pi radians. Okay, that is different than for the sine and cosine graphs. All right, so we've got a couple more problems that we're going to go over. Okay, so let's take a look at it. Y equals -3 plus 4 tan 2x. Okay, so we have first a dilation that we want to talk about of scale factor 4 with respect to the y's. Okay, that 4, that means when you multiply it outside, that's for the y's. All right, and this multiplication of 2 right there, okay, that's inside, so it's actually a scale factor of 1/2 that I'm going to apply to the x's. Okay, so now that is going to change the period of my graph. So the standard period is pi, but now it's being compressed down by a scale factor of 1/2, so it's going to become pi over 2. And from there, that means that I'm going to change the scale of my graph, right? So I got to take that pi over 2 radians, that period, I got to divide that into 4 equal intervals to make for the cycle, which means multiply pi over 2 by 1/4, which is pi over 8. Okay, so I'll bring that into play. Anyway, so now I've got one more transformation to do. Now you see this -3 right here? That really is a -3 being added on to 4 tan 2x. So I could really take that, and I could actually just bring that back right here as -3. That'd be the same thing, right? Because if I add the negative, right, that would be the same thing as plus -3 that I see up here. But seeing it in back like that helps me to realize that this is just going to take the graph and move it down 3. See, this is not a negation, that means a reflection. This is a -3, okay? Had there been a subtraction here in between, okay, the -3 and the 4 tan 2x, then that would be a negation, which would be a reflection. We'll actually see that in our next example. All right, so anyway, let's start by making a graph that has just the dilations in it. Okay, now what I'm going to make sure of for this one, okay, is that I have enough room to go up 4 and down 4 on my y-axis. Okay, reason why I want to do that, if I want to count every box as one unit, that is I have to vertically stretch by scale factor 4. So instead of these y values being 1 and -1, that's going to vertically stretch to be 4 and -4. Okay, then I've got 4 intervals to make for the cycle. That's going to end at pi over 2 radians. Okay, and it's going to have a scaling of pi over 8. So 0, okay, 1 pi over 8, 2 pi over 8, 3 pi over 8, and then there you go, 4 pi over 8, that's pi over 2. All right, so I'm going to start at 0, 0. Okay, that wouldn't change just because I vertically stretch, okay, or horizontally compress. Then after one box at pi over 8 radians, I'm actually going to go up to 4 now, okay? And then the next box over, which is at pi over 4 radians instead now, that's going to be my asymptote, my vertical asymptote, and then I disconnect. Now be careful, okay? Try not to make this look like too wavy in here. I know it's not the easiest thing to do when you vertically stretch, okay? But you want to show that the graph is not really linear. You don't want to make a straight line here. You're going to give it like a little curve if you can. And you want to make sure you show that it is still going to get infinitely close to this vertical asymptote without reaching it. Okay, you don't want to make it look like it's going to go perfectly straight up. It is going to get closer and closer here as it keeps going up. And you don't want to make it look like it's going to veer away or go through the asymptote. Okay, so just do the best that you can with that. Anyway, let's keep going. So at 3 pi over 8 radians, right, one box after the asymptote, I'm going to be down here at -4. And one box later at pi over 2, I'm going to be at the midline. Okay, and then that is what that looks like. Okay, so now before I do my second cycle, oops, so I forgot to mention here, I want you to do 2 cycles here with this graph. Okay, I'm going to actually take time to do the vertical translation first. Okay, now I know I need to go down 3, so when I make my x-axis here, I am going to, I'm going to put a little bit higher because I know I don't really need to go that high on my y-axis anymore because I'm going to move the whole graph down 3. So that y value of 4, I really just need a y value of 1 that corresponds to it. But what I do need though, right, is I do need that at at -3. That's going to be my midline, okay, because the whole graph is going to go down. And then I also have, instead of -4, I'm going to go down to -7. So actually, we need to extend this a little bit more here. Okay, so -3, -4, -5, -6, and then -7. All right, so I've got the same scaling here on the x-axis. Okay, so I'm going to go 0, right, 1 pi over 8, that's my scale. Okay, 2 pi over 8, reduce that. 3 pi over 8, 4 pi over 8 reduce that. Okay, so there you go, 4 equal intervals to pi over 2 radians, because that's my period to make for the cycle. And then remember, all these points are just going to go down 4. So this is down 3, sorry. So instead of 0, 0, now it's at 0, negative 3. Instead of pi over 8 comma 4, now it's at pi over 8 comma 1, right, because I just moved down. And then here's my asymptote still. All right, and then another box later, instead of 3 pi over 8 comma negative 4, now it's at 3 pi over 8 comma negative 7. And instead of pi over 2, 0, now it's at pi over 2, negative 4. And then there we go, okay? So that is what one cycle looks like when it's been moved down 3, okay? But I want you to do 2 cycles, so I'm just going to suggest that we do our second cycle heading off in the positive x direction. So I'm going to do 1, 2, 3, 4 more boxes to do another cycle, okay? Let's put the scaling, let's use the scaling to put more radian measures down here. So, right, scaling is pi over 8, so every box is pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So now I'm at 5 pi over 8. Okay, 6 pi over 8 reduces. This is 7 pi over 8, and then that's 8 pi over 8. Okay, so pardon my barking dogs. And then, so one box over is still going to be at that y value of 1, just like that is. And then next box at 3 pi over 4 radians is going to be my asymptote, and then that goes up. And then at 7 pi over 8, we're going to be down here at the negative 7. And then at pi, we're going to be down here at the negative 3. Okay, and then there you go. There's your second cycle. All right, so we've got one more problem that we are going to do together here. And I don't think I have enough room on the front, so I'm going to flip to the back here. Okay, so we are going to do y equals 4 minus 2 tan of x over 2. And I'm going to specifically ask us to get this sketch from negative 2 pi to positive 2 pi, okay? So we're going to have to determine how many cycles that is, and we're going to, head off in the negative x direction, see what that looks like. Okay, so I'm going to suggest the first thing we do is graph based on our dilations. So we've got a dilation of 2 to the y's. Okay, so that multiplier of 2 stays as a scale factor of 2 with respect to the y's. It's outside. Now this right here, see x over 2, that's the same thing as saying 1/2 times x, right? Divided by 2 is the same thing as saying 1/2 times x. So this multiplier of 1/2, that is actually a dilation of 2 to the x's. Okay, so I gotta reciprocate that, right? So now it's being horizontally stretched. And I've also got right here, right? So those are gonna be done first. But then I've got this negation, and that really is a negation because you see this positive 4. So I'm going to rewrite that at the end as a plus 4, okay? And so that negation, that is a reflection that's going to be done over the x-axis. And then this plus 4 at the end, that's going to send the graph up 4 units, okay? So let's get, let's come back here. Let's get our period determined, okay? So the standard period would be pi. But now I'm multiplying it by a scale factor of 2, so now it's 2 pi, okay, which means my scale is take 2 pi and divide it by 4 equal intervals. That reduces down to pi over 2, so now my scale is pi over 2, okay? So I've got 2 different, actually 3. I'm going to make 3 different graphs here. I don't want to put them all on the same set of axes with tangent because it really gets to be rather crowded looking because of all those asymptotes and everything. So we're going to just start with the dilations as we've done before. So scale up 2 and negative 2 on the y-axis, okay, because I'm going to vertically stretch. See that right there? Okay, I'm going to vertically stretch by scale factor 2 of the y's. And then at 4 boxes in, I know my period is 2 pi radians. So that's how many radians I put at the end of the first cycle, 2 pi radians. And then I'm going to scale by pi over 2. So 0, 1 pi over 2, 2 pi over 2 would be pi, and then 3 pi over 2, 4 pi over 2 would reduce down, okay? So I start at my midline point at pi over 2, then I'll be at a y value of 2, and then I'll have the asymptote, right? And then the next box over at 3 pi over 2, I'll be down at negative 2, and then I'll be at the midline point there again at 2 pi, and there you go. So this is what one cycle looks like, okay? Now, as per my instructions are concerned, right, I'm going to I only want to go to 2 pi to the right. So that's good. That's with one cycle. And hopefully you see this is really just asking you for one cycle going off on the left, because if positive 2 pi to the right makes one cycle, then negative 2 pi to the left would make another cycle. So anyway, let me try to erase a little bit here. So all right, oops, pardon me. Okay, so now I'm going to take this graph. Okay, I did that. I'm going to do the reflection. Okay, it's a reflection over the x-axis. Okay, maybe you don't need to make another graph just for this, especially if you've got like colored pencils or something that you can do with, but I just wouldn't want you to get confused by putting that graph on top of this one, because it's, there's all, like I said, it's with the asymptote, it's a little hard to see. So anyway, I'm still going to keep that scaling on my y-axis of 2 to negative 2. I'm still going to have that same scaling on my x-axis here from 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now, instead of going from 0, 0 up, I'm going to go from the midline point down, okay, because I'm going to reflect over the x-axis. So pi over 2, 2 before, now it's going to be pi over 2, negative 2. And I'm still going to have this asymptote here at pi radians, and then the graph goes down. And then instead of 3 pi over 2, negative 2, it's going to be 3 pi over 2, positive 2. It's still going to have that point right there, and there you have it. Okay, so that's just a reflection of the x-axis. And last but not least, so I'm going to actually make another set of axes right here, just so I can show you, without it getting too crowded and confused, that we're going to go up 4. So I'm going to bring my x-axis a bit lower, right, than what I had before, because I know I need to have my midline be at 4. Okay, so I'm going to sketch that in right there. That's my midline at 4. And then I'm going to have this y value of 2 has to go up 2 to be 6. And that y value of negative 2 is actually going to be up here at positive 2. So now you see what I had as negative 2, 0, and 2. That had to go up 4, right? So just add 4 to each of these values and you get these right here. So I'm still looking at having 0, pi over 2, pi, 3 pi over 2, 2 pi to make for the cycle going in the positive x direction. And instead of at 0, 0, though, I'm just going to be at 0, 4, because that had to go up 4. And instead of pi over 2, negative 2, now it's at pi over 2, positive 2. Okay, but the graph still goes down, down, down forever towards that asymptote. Okay, see, but the whole thing just went up 4. And then here, okay, instead of at 3 pi over 2, 2, now it's at 3 pi over 2, 6. And instead of 2 pi 0, now it's at 2 pi 4. Okay, so that is what the graph looks like when it's just been moved up 4. But again, I've got this in the directions here about going to negative 2 pi as well as positive 2 pi. So I'm just going to copy and paste. So I'm going to take this right here. I'm going to copy and paste it right over. Then this piece right here is what's going to go here. So I'm going to, this midline point just kind of matches right on top of this one. And then this point would be right there. Okay, so yeah, that's one box to the left. So that would be one box to the left there. And one more box to the left would be at an asymptote. And I just go up. And if, think about it, if this is pi over 2, one box to the right, and this is negative pi over 2, one box to the left. See, and then positive pi over 2, so there we go, negative pi, right, negative pi. And then this would be negative 3 pi over 2, and then that would be negative 2 pi. So anyway, that's what that graph looks like there. And then this piece here would have to mimic over there. So one more box later, this point right here, which is at negative 3 pi over 2 radians, set a y value of 2. And then finally at negative 2 pi, I'm back at the midline, which is at that y value of 4. And then I'll just connect. All right, so that is what 2 cycles looks like. I mean, I didn't specifically say that it had to be 2 cycles. It was up to you to determine that that meant 2 cycles, but notice how I didn't go off in the positive x direction for the second cycle. I followed, specifically what that, the set of directions is about. All right, so that is it for tangent graphing. We're not, like I said, we're not going to do phase shift this time, but if you continue on to a pre-calc class next year, then you will do a lot more with trig graphs, and you'll get to doing phase shifts with the tangent. All right, hope all is well. Bye.